So today we'll be talking, we'll sort of pick up where we left off last time with Ludovic, who talked about manipulating data in R using some common tidyverse functions. Today's session will focus on a particular package called tidyr, and we'll go over some terminology at the beginning, and then we'll kind of dive into particular parts of that package, particular functions that you might find handy in working with your data. So let's start with what do we mean by tidy data? This is something, that's very inherent to the tidyverse. It's in the name. And this is a way of understanding kind of how R interprets different data structures. So data is considered to be tidy if each column is a single variable, each row is a single observation, and each cell has a single value. So for example, if you look at this data set or this snapshot of a data set on this part of the slide, hopefully you can see my mouse over here. We're kind of turning this into tidy data. So over here, you can say each column kind of has multiple pieces of information. It has fuel efficiency in miles per gallon, but also kilometers per liter. So it has more than a single observation in a cell, more than one piece of information per column. But then over here on this part of the slide, we see then that is now we're kind of using one observation is isolated into one row. For example, over here we had two columns that were talking about fuel efficiency. Now fuel efficiency is isolated to one column only. And you can see the type of road is separated here. So this is, might seem trivial. It might seem like, okay, these are just two different formats of data. Why is this useful? Well, I hope to show you in the next kind of few slides why it's useful to have data set up in a tidy manner like this versus this in terms of how R understands it. So R kind of takes tidy data in a certain way for manipulating it. So it's useful to kind of separate observations into single rows like this. And again, this might be a little bit unintuitive right now. Tidy data it is a little bit confusing to wrap your head around, but I'm hoping kind of through these examples, it'll become more clear what tidy data is. So before we jump into that, I'll briefly mention Tibble. So this is something that has been brought up before, and also if you were here for the first series, or when we did the first sort of learning series, we mentioned Tibbles. Tibbles are they're like data frames, they just have a few more features than data frames in R. For example, Tibbles allow you to have blank spaces and numbers as variable names, whereas if you work with data frames, you will find that you get errors when you have numbers and variable names, and then you can have blank spaces as variable names, but you have to use these sort of backticks to refer to them. Tables are also nice because by default, if you print a data set, it'll try to print the entire thing in your console, but a tibble will only ever show a snippet, so it shows the first 10 rows. It is a little bit more strict than data frames in that indexing requires exact matching, meaning it won't look for similar enough columns. You'll have to kind of call columns exactly. You can create new tibbles just with the tibble function, or you can change existing data frames into tibble. So you'll know it's a tibble because when you print out a tibble, it literally says a tibble. And tidyr and tidyverse in general often kind of works with tibbles. So in tidyr, it's quite handy to work with this data format. So now we're gonna get into different tricks you can do using the tidyr package. You can see the little symbol in the top right of the slide over here. This is, I believe, downloaded automatically when you download or when you install tidyverse. You don't need to load it separately. If you've loaded tidyverse, tidyr should already be loaded, since tidyverse is sort of a package of packages, but you can also kind of load this and work with it in isolation. So the next few slides, we're going to go through some handy functions within this package. The first of which is pivot longer. So pivot longer, basically, it does the exact thing that we saw a couple of slides ago. So if you have a data set which you would like to, if you have a data set which you would like to basically separate each of these cells, if you would like to lengthen that data set, as you did here, you can pivot it and stretch it out almost. You can think about it as stretching out your data set. You can specify which columns you would not like to stretch out. So over here, ID, nothing needs to change really in ID. The entries will still be car1, car2, and car3. But over here in this particular example, what I'm doing is I would like all of these values to turn to be in one column. So basically I need to have 6 rows and one column that has all of these fuel efficiency values. So which is why I specify values to MPG. So you can see values have gone to a column called MPG. On the other hand, names to road. So names it draws from these column headers. So it'll take city and highway and turn them into a column called road. So it's taking the names from city and highway and then it's adding it to this column called road. So just take a moment here to see how this function is working. We're pulling the values. So the values basically take all of the values in this data set except for ID, because I've specified !ID. So don't consider ID. But all of these other values, so these 6 values in the data set, it goes under a column called MPG. And the names, the 2 names in this data set, so city and highway, again, not ID because I've specified I don't want to consider ID. It'll put that in a column called road over here. And then with that action, you've kind of expanded your data set lengthwise. Now you can do the opposite too. If I have a data set that's already long and I would like it to go into a wider format, I can use the pivot wider function. And you can see over here, this is syntax you should recognize from the previous session, because this pipe operator over here is the exact same as before. So you can, all of this is tidyverse language. You can use the same kind of language with tidyr. So the function here, pivot wider, it works in the exact opposite way. So now I'm concerned with where I would like to draw my column names from. So over here, I'm telling it, draw column names from the column called road. So over here, city and highway should be my column names. And over here, values should be drawn from MPG. So by default over here, you can see I haven't said anything about ID. So the ID column won't be touched. It'll just simply draw the column names from road, and it'll draw all of the values from MPG. So it works in the exact opposite way that pivot longer does. And we'll see these in a practical example after these slides. Another action you can do is splitting columns. So over here, as we saw in the first example, we have more than one value under fuel efficiency, right? So each of these is given, each of the fuel efficiency values is given both as miles per gallon and kilometers per liter. But suppose, for example, I want those to be separate. I don't want them to appear in one cell. I can split it so that each row contains its own value, for example. There's also a way to split it width-wise so that, one column is MPG and one column is kilometers per liter. But this particular example shows you how to separate it by rows. So over here, it's called separate longer. The function is separate longer delim. So that's a delimiter. So basically that specifies where I want to separate. So over here, I'm saying separate longer delim. I would like to separate my efficiency column. So that's this column right here. And I specify that the delimiter or delim is this /. So everything before the / should be in one place, and everything after the / should be in one place. And these 2 things should be separated longer. So you can see how it goes from this data set to this data set over here, because now you can see 19 and 8.1 are split up, and they'll appear by default underneath one another. So it's not like you'll have all the MPGs together and KPLs together. Once you split it, it kind of automatically appears underneath that row. So you can see the data set retains the exact same column names as before, just adds more rows. So this could be a handy function to work with your data as well. And exactly as I said before, you don't have to separate it lengthwise. You can also separate it widthwise. And as you guessed it, the function here is separate wider delim. So the previous one was separate longer delim. Now it's separate wider. And again, I should specify the column I would like to separate. The delimiter again is at /. Now this has an additional argument in this function because now I have to specify, because now that I'm doing wider separation, I no longer have the same column names as before. So if you're separating longer, you're just adding more rows. So nothing happens to your column names. But over here, because I'm separating wider, I have an additional column. I have the same number of rows as before, but the additional column is there. So I have to specify what the two column names are that I'm separating efficiency into. So I said there's one efficiency or EFF MPG and one EFF KPL. But you can play with this and specify whatever you would like your column names to be. So you can imagine this is a very handy thing. In hospital data sets, it's often one way this is handy is, for example, blood pressure. So blood pressure is often noted as a number / another number, right? Your diastolic and systolic blood pressure are often reported together in the same cell. But it could be hard to manipulate those numbers, right? Because you consider diastolic blood pressure and systolic blood pressure separately. So that could be a useful way to kind of separate these two and work with them on their own. So similarly, in the previous two examples, we saw how to separate different values in a data set. You can also quite easily unite them as well. So for example, if you want fuel efficiency in this particular example, if I want fuel efficiency to appear under one column name rather than two, I can use this unite function. Again, it'll ask me, now you can see efficiencies in quotation marks because I'm creating a new column called efficiency. Efficiency doesn't yet exist in this data set. And I'm creating it using going from FMPG. So this colon over here just specifies which column I'm starting at and which column I'm ending at. So over here, I'm starting at EFF MPG, ending at EFF KPL. If I had a third column, I could have also ended there. You can unite more than two columns. That is totally fine. Here, I'm just uniting two. So I've specified where I'm starting the unity and where I'm ending the unity. And again, I can specify what I would like to separate them with. So over here, I said I'd like to separate them with the /. So it has added a / there. It doesn't have to be /. You can separate with an underscore, a space, even whatever kind of your data set demands. Before jumping into combinations, I'll pause for a second there to see if we have any questions on pivoting or separating or uniting. And if not, that is a-okay. We'll also see this in an example soon. Okay, solid. I will continue. So another useful operation using tidyr is combinations. So for example, here I am returning all possible combinations of specified variables, whether or not they actually appear in the data. So this is handy if you are working with data that is related to each other. For example, over here, BMI might be related to diagnosis. So perhaps for my particular research question, I am concerned with what are all the possible combinations of BMI and diagnosis, regardless of whether they're in my data set or not. So for example, in my data set, I have somebody with high BMI who's got a positive CVD or cardiovascular disease diagnosis, a normal one with positive diagnosis, normal with negative, and low with negative. You can see there are some combinations that don't appear in my data set. For example, someone with low BMI that has a positive diagnosis. I don't have anybody like that here. Similarly, I don't have anybody with high BMI with a negative diagnosis. But this expand function will print out all the possible combinations that you could have regardless of whether or not they appear in your data. And this is just kind of helpful in understanding which categories there are, so that you almost have like a reference combination list to compare to, and you can see of these, all these possible combinations, which ones appear in my data set and which ones don't. And over here, I've chosen to focus on diagnosis and BMI category, but you can similarly add in or focus on other variables to see which combinations could exist. Over here, for example, this takes the same thing a little bit further. So not only does it list all possible combinations of diagnosis and BMI category, it'll actually show you rows. So it'll show you the complete data set, and it'll add rows where combinations don't exist. So the previous one you can see just focused on diagnosis and BMI category. This one now added the age group variable back in. And then it puts an NA for age group where that combination doesn't exist. So for example, there's nobody in our data set with low BMI who has a positive diagnosis, and there's nobody in our data set with a high BMI and negative diagnosis. So we've got NAs listed over here, if that makes sense. And this can also be useful again in extending the previous expand function to understand what combinations do not actually exist in the data set. So over here now we can take this one step further. So over here on the left side of the next page, we have the same, we're working with the same table over here. So suppose we have a data set here that has missing values, right? So missing values often appear as NAs in the data set. So NA just is another word we use quite interchangeably to say we have a missing value in this data set. And missing values are actually very, very common. If any of you have worked, for example, with hospital records before, missing values are really, really common there. There are often ways to work with missing values. And sometimes, some cases, it's appropriate to drop them. For example, if you don't have that many missing values, it is valid to remove them from your analysis. For example, if you're doing any sort of regression analysis or statistical analysis that requires a complete data set, and you notice that, okay, I only have 2 or 3 missing values, it is valid to just remove those missing values. But to note, you shouldn't remove, for example, when I'm removing a missing value, it means removing that entire row. So be really careful with this, because sometimes removing an entire row can be harmful, especially if you have a lot of missing values. So we only really recommend doing this if you don't have that many, and if it is valid with your statistical analysis to drop them. But it's a really, really easy function, luckily. So the simple drop underscore NA, you don't have to put anything in the brackets, and then that'll basically remove any row in its entirety that has any missing value. So you can see these rows here. So row 2 and row 4 have a missing value for age group. And if I say CVD data complete drop NA, it'll just drop those 2 rows entirely. So it's quite an easy function over here to get rid of any rows with missing data. You can also fill in missing values. Now, again, this is to be taken with a grain of salt, and you have to kind of also do this quite carefully. So you can choose to fill in missing values. For example, with one of the ways to fill it in is just to use the value that appears just before it. And in tidyr, it's a function called fill. So what fill will do is over here, if I say fill age group, basically any missing value for age group, it'll fill it with the value that appears just above it. So you can see it fills this NA with the 70 to 79, and it fills this NA with 80 plus. So all it has done is it's pulled the value from above and it has filled this in. Again, this is quite handy if you have only a couple of missing values. This is actually really, really good for if you're doing any sort of spatial epidemiology, for example, and let's say I have one sort of region name or geographical coordinate and a bunch of rows of observations for it, but only kind of that first row has the geographical coordinates filled out. I can say fill, and then it'll kind of repeat that coordinate for all of that data. I see there's a message. what is an advisable cutoff point percent for dropping NA in our data set for analysis to be still statistically significant? That's a really good question, actually. Um, this is, I don't know if there's a rule of thumb. I've always been kind of cautioned against dropping missing values um, where I can. And people just say if there are few missing values, you can drop them, but few is very much kind of up to interpretation, I guess. I don't know if anyone knows of a rule of thumb, actually. If Duncan, if there is any you know of.
Yeah, actually, that's a good question, but I think it will depend on the problem, because
Mm,
times, as you've said, that it's actually recommended for you to look for ways of filling the values than actually dropping them, because
mm,
at the end of the road, it may end up affecting your analysis, be it regression, be it predictive, or anything. It just ends up affecting it. So, but percentage, the cutoff percentage, I think that depends on the problem.
yeah. Yeah, I don't know if there's a sort of hard and fast rule for what percentage. It's kind of depending, yeah, exactly as Duncan said, on the problem, up to your interpretation of what few means. But again, yeah, filling in is usually better than removing altogether, because when you fill in, you're kind of filling in one value, but then if you remove a row, you've also lost all this other information for that patient.
Exactly, and also I think um, it may also mean that it also depend on the data type that you want to fill. Like for the age group, uh, there's nothing much really we can do. We can just fill the age group. But
Mm-hmm.
things like let's say for example like a BMI, you can think of
Mm-hmm.
maybe filling in with with the mean of the BMI in that group.
Exactly.
Yeah. Yeah, so as I said, it will just depend on the problem and the category or the kind of data which is missing.
Mm-hmm. Yeah, thank you. Yeah, that's exactly it. There are different ways. I see people have talked about or mentioned imputation in the chat. So these are all different ways. I
Yeah.
think imputation is more of an umbrella term, and there's different ways to impute values. But yeah, as Duncan said, there's a few different ways to impute missing values. And I think in the next slide, there's another example. Oh yeah, actually this one just shows fill again, but shows fill in one way where it might be very appropriate to fill it in. So for example, if age group, um, if it doesn't really make sense to use fill, thank you. But yeah, this slide just shows an example where using fill would be very appropriate. And this often happens in things like clinical records, where you have a time frame or a geographic area that's only filled in for the first row. So even though all of these rows correspond to January, January is only appearing in that first one. So I use fill to kind of fill in the blank months with ones that appear before it. So this is a very handy way to deal with that. Um,
Mm.
you can also replace blank values. Um, if you want to maintain um, your rows and not remove them for analysis, you can replace any blank values with the word unknown, for example. So this will make sure that row is kind of kept in analysis, but then it basically creates another category for age group. So if I say list age group equals unknown, replace NA, this will replace any blank within age group with the word unknown. And unknown is now its own category within age group. That is another way to kind of deal with missing values. And as Duncan said, another quite common way, especially when you have continuous data, is to replace blanks with means or medians. Um, and that's another way to deal with missing values. I will say there are kind of more complex ways of dealing with missing values. Actually, I have a friend who's like doing his entire PhD on methods of imputation. So it gets very, very complex. And if you are curious, I do encourage you to look more into different methods of dealing with missing values, because unfortunately this is inescapable. Any data set you have will most likely have something missing. These few slides are just to give you an idea of ways in which you can deal with them, but there's kind of a whole, I'm sure a whole textbook has been written on this and how to deal with missing values. So those are quite handy to look into. So I would recommend. And so everything I've gone through, so all the various functions within tidyr that I've gone through are actually summarized very handily, if that's not a word. There's a handy summarization of these functions in a cheat sheet online. So I've linked it over here at the bottom of this slide. This is what the cheat sheet looks like. So for example, it goes through what tidy data is, it goes through tibbles, how to construct them, what makes a tibble a tibble. It goes through reshaping data, so that pivoting longer and wider that we saw in the first couple of slides. It also shows how to expand and complete data. So this is the different showing the different combinations of variables. There's split cells as well over here, and it has handy visuals. And then finally, missing values. And these are all the core functions of this package called tidyr. So this is a very handy cheat sheet to have on hand. So would recommend checking this one out. And now, before we jump into the code, I'll pause to see if there's any particular questions on any of these functions.
Ashna, I have something. Maybe it's more of a comment.
Sure.
I've actually noticed that in the example that you gave for complete in your slide,
Yes.
if you go to the complete, then
Uh, this
drop
one.
in the next slide. So it means
Yes.
that if you complete and then you drop an A, you end up to the original data set. Is that always
Oh
the case?
yeah. Actually, yeah. This does
Okay.
go to the original because it kind of goes from the original to now saying complete, and then
Uh-huh.
CVD data complete, you drop NA. Now it's gone back to the original.
Yeah. Yeah. Okay.
At
Great.
least,
That's only comment. Yeah.
yeah, that's it's a handy comment. Actually, yeah, it's a good thing to notice because the so complete this function actually introduces new rows. So it introduces rows that don't exist in your data set, right? Because there's no patient with low BMI who had a positive diagnosis, and there's no patient with high BMI with negative diagnosis. So they sort of introduced two artificial patients in the data set. So then the drop NA allowed us to remove those artificial patients and go back to the original.
Yeah. Exactly.
Yeah, awesome. So I will toggle over to, where is, R is over there. Okay. So hopefully people can see this. If at any point it is not big enough, let me know. So over here. So this code is available on RFC, I believe. So do feel free to check it out over there. It uses the HIV data set that you will have seen kind of from previous sessions as well. So it's the same data set that we're working with this time. And again, so I'll go through this and I'll pause for any questions if people have questions, but I do encourage everyone to try this out on your own time as well, because it is handy to kind of play around and get used to different things. So we'll start over here. We'll load 3 packages over here. So tidyverse, I'm just loading all together. tidyr lives within tidyverse, so it'll be loaded automatically. I'm loading up Rio, so that'll help import data. Oh yeah, thank you, Athmani. I see he's linked to the code file over there. I'm using Rio to help import data. And I'm using the here package to anchor code over here. So I'm gonna go ahead and run this. I will anchor my code. So over here, you can see exactly where the code lives on my computer. This will look different for you as well, depending on where you've downloaded it. Make sure to download the data set in the exact same place that the code is saved. So my data set also lives within the session 3 folder. So if I run this, it'll quite easily import my data set. I'll take a quick look at the data set over here. Again, it's the same one we've been working with, so you will recognize a lot of these hopefully from previous sessions. So this data set has patient ID, age, gender, occupation, HIV status, so 0 for negative, 1 for positive. Those who are diagnosed positive for HIV also have CD4 and viral load counts over here. We have hospital diagnosis. We have an extra variable here. Comorbidities, date of sample collection, diagnosis, type of diagnosis, type of case management, and then finally prevention management, if it existed. So this is a data set you should be familiar with, but I will say tidyr is also a great way of kind of familiarizing yourself with the data set. So over here, we're going to start off for these examples. We'll focus on 2 variables in this data set, type of diagnosis and type of case management. So the count function allows us to just look at how many unique combinations there are of these 2 variables within our data set. So if I go ahead and I run this, it'll print out in my console. So you can see there's 79 patients that had confirmatory diagnosis and community-based care management, 100 patients that had inpatient case management, confirmatory diagnosis, and you can see kind of the number of patients that fall within each of these category pairs. Now what we'll do, basically, so we see that there are 3 different types of case management, right? There's community-based care, inpatient, and outpatient care. And similarly, there are, I believe, 3 types of diagnosis, right? So it's confirmatory diagnosis, follow-up, and initial. So over here, we're just going to make a data set out of this. I'll call this data long. So here, if I say data long, and you can take a look at data long over here. So this is our data set. It has 9 rows over here. It's the exact same one that we saw in our console. So we'll just take a quick look at data long. We'll print it out in the console over here. Is this a Tibble? That's something we can actually check. You can say, is Tibble data long? False. So it's not a Tibble. It's very easy to turn this into a Tibble. Let's go ahead and do that and say as Tibble data long. And then once again, now we'll print it. And now we know it's a Tibble because it says a Tibble. It's a very easy way to check. Now it's a Tibble. You can see it has a few more features than it did. So when we printed it out as a data frame, it printed out quite simply. Now as a Tibble, it has a few more pieces of information. You can see the dimensions it prints out. You can see what types. These are all character variables over here. This one's an integer, so it's a number variable over here. So it prints out a little bit more information. So over here, let's try reshaping this a little bit. We're going to pivot this wider. So meaning we will have an additional column over here. We're going to say take the names or additional few columns. We'll say we want the column names to be from type of case management. So my column names should be community-based care, inpatient, and outpatient. And I'd like my values from this n column here, so the number of people. The type of diagnosis I don't want to touch for now, so that won't be relevant for now, but you'll see how it still appears within our data set. So for example, if I say data wide, and now let's take a look at data wide. So it has gone from,
Ashna,
oh yes.
there's a comment in the chat. You're too fast.
Oh, sorry. Okay, I can slow down.
Yeah.
I will slow down over here. So let's go back to, we'll go back to here. So we'll start with our data set, data long. So data long is simply, we're looking at the combinations of type of diagnosis and type of case management in our data set. So this is what data long looks like. So in data long, you can see there's 2 variables we're focusing on, type of diagnosis, which has 3 different types of diagnosis. So our patients have either confirmatory diagnosis, follow-up diagnosis, or initial diagnosis. And similarly, there are 3 different types of case management. So our patients either have community-based care, inpatient care, or outpatient care. And this N column just shows you how many patients of because we have 1,500 patients altogether in our HIV data set. This N shows how many of those 1,500 fit into each of these categories. So we have 79 patients that had community-based care as their case management, and the type of diagnosis was confirmatory. We have 100 patients that had inpatient case management that had confirmatory diagnosis, and kind of each of these numbers represents how many patients fit within this. So we're kind of using this as an example of a data set and just going to see how we can manipulate this little portion of our data. So what we're going to try to do now is, so this over here is technically tidy data, right? So each row has its own information. Each column is unique. There's only one piece of information per cell. Suppose we would like to go from this to a table that has where the columns are one type of case management and the rows are a type of diagnosis. So if we wanted to go from long format over here to a more of a wide format. So that's what I'm doing in this these lines here. So lines 37 to 40 are basically taking data long, so this data set, and turning it into a wider data set. And I'll show you how it's doing that. So it's using this pivot wider function from the tidyr package. It's saying, I would like my column names to come from type of case management. So type of case management is this column here. So type of case management, meaning I would like my column names to be outpatient, inpatient, and community-based care. So those should be the column names. Values from N. So meaning all of the cells in my new wide table should come from this N column over here. I'm not saying anything about the diagnosis. So type of diagnosis doesn't exist in this function here. So you can see how it'll automatically manipulate type of diagnosis. So when I run this and I create data wide, so if we take a look at data wide, we've gone from data long over here to data wide. So it has taken the names from the type of case management has become now column names. So you can see the column names are community-based care, inpatient and outpatient. And the values are all of these cell entries. These are coming from N. So this N column over here, this has now been used to fill these in. And you can see type of diagnosis we didn't specify, so type of diagnosis has remained as a column in our data set. And you can see how over here, this is easier to read than data long over here. So this is a little bit more of a complex table. Data wide is often easier to read. So you can say number of patients that fall into each type of diagnosis and case management system. This is now an easier data set to read. So it's a handy way of summarizing tables like this. So I encourage you to play around with this. So for example, if we changed this instead to type of diagnosis and did that, now data wide would look a little bit different. So now type of case management has remained a column and type of diagnosis has turned into the column names, confirmatory, follow-up, and initial. So do play around with this, see what different types of tables you can create. That kind of shows how to pivot the tables. Does that make sense? If there's any other questions, we can kind of try things out together here. If there's no questions, feel free to try playing around, and you can always use our forum on Afredac, and we do have our what's it called, our RFC session next Thursday. So if there are things you'd like to try out here and you have questions about, you can bring them next Thursday and we can try them together. So over here now, suppose we now want to consider a third column. Okay, let's add prevention management. So in this session here, I'm creating a data subset. And if you remember from the previous session, we talked about select being a handy function to use. So here I'm selecting 3 columns I would like in my data subset. So here I'm just creating a data subset with type of diagnosis, type of case management, and prevention management. So let's take a look at what we just created. So if we take a look over here, so these are the 3 columns. We have the same 2 ones we were working with before. Now we have a column called prevention management. And what do you notice about prevention management is you see a lot of missing values, right? So most of these are NAs. So over here, let's suppose we only want to focus on those that have complete information. So I'm using this drop NA function. So I'm saying I'm creating a new data set called data subset complete. I'm saying from data subset, just drop the NAs. So now we have data subset complete. Let's take a look at data subset complete over here. So it has 149 observations. So there should be 149 patients here that have complete information for all 3 of these variables. Okay. So now let's take a look, for example, at combinations. So this is just out of curiosity. I'm looking at what are all the possible combinations, because you can see if I look at data subset complete, type of diagnosis, there's 3 different types of diagnosis over here, right? And 3 different types of case management. What about prevention management? So we have 1. Over here, you'll notice also NA, keep this in mind. So these are NAs that were characters that were not removed. We have not on prep, so that's a 3rd category. And we have prep as a 4th category. So there should be 4 different types of prevention management. So there's 4 categories here in prevention management, 3 in type of case management, and 3 in type of diagnosis. So let's take a look at the combination. So we're going to use this expand function from the tidyr package, and we'll take a look at what are all of the possible combinations. Now remember, expand looks at all possible combinations, whether or not they appear in your data set. So over here, you can see how many rows there are. There are 36 rows in total here, right? So this is saying of all the 3 different types of diagnosis, of all the 3 different types of case management, and the 4 types of prevention management, what all possible combinations can we have, regardless of whether they appear in our data set? And that's what you can see over here. And again, this could be handy just for exploring your data a little bit more, for comparing your data to something else, things like that. So as we said before, we noticed that actually there's an NA that appears here, but we removed all of the blanks. We can use the previous lesson to recode this variable to actually remove NAs. So now over here, this is just a bit of a recall from the previous session. So what's happening in this part of the code is that I am looking at the data subset complete data set. I'm using mutate. So if mutate seems unfamiliar to you, don't worry, you can check out the previous session for more details on this. Mutate essentially lets us manipulate the data set. So I'm saying I would like to manipulate this column called prevention management, and I'd like to recode it. So recode means I would like to take anything that appears as NA over here. Oh, hello. I'd like to take anything that appears as NA, but I'm putting in quotation marks. And I'd like to replace it with a blank. So NA underscore character I'm using is because if I just use NA, it might throw an error. So NA character is still a blank, but kind of fits within a character column. It's a little bit confusing. But basically what this will do now is this will take all of these NAs and it will turn them into blanks. So that's what we'll do. We will turn them into blanks now. So pay attention over here on the right side. So right now, data subset complete has 149 observations. So if we drop missing values again, so if I run this line, you can see this has now changed to 138. So there were 11 of those rows that had NAs as characters. So those 11 rows are now gone from the data set. And once again, now let's take a look at combinations. So now you can see we only have 3 types of prevention management, 3 types of community manage or case management, and 3 types of diagnosis. So we have all of these different rows for all possible combinations in our data set. And that is actually the bottom of this code. The code itself wasn't very long because I wanted to encourage you to play around with it, and we will play around with it a little bit more in the next session as well. But something that you can try over here, for example, is looking at different combinations of other variables in this data set. You notice that we also spent a bunch of time removing blank values over here. You can also try replacing blank values with something else where it makes sense. So next week we'll play a little bit more with this. But for today's session, I just wanted to get you kind of used to this method of kind of manipulating the data. It's not entirely intuitive all the time. So things like pivoting wider and pivoting longer, it is a little bit confusing. But it's a matter of kind of practicing with the actual code and with the data and seeing how that's why I tried to include many tables in the presentation today. I think it's quite helpful to see how exactly the data sets and the tables change with each of these functions. But that's just to give you a quick idea of what tidyr is. It's a very, very handy package for manipulating data, but also just for exploring it. I know in my personal experience, I like to use it to explore data quite a bit. So this expand function is quite handy for exploring the data as is complete. And then the pivoting longer and wider is also quite useful in summarizing your data in different ways. I'll pause there to see if there's any questions or if there's any things that people want to try out now. If there are no questions, that is also okay. You can give it a try on your own time. I know Athumani has linked the code and the relevant data set as well. That's really the best way to sort of get familiar with this, is to try out these and play around with each of the functions and see what works, what doesn't work, and especially the stuff that doesn't work. Do bring to us, and then we can figure it out together. I know it's a little bit of a shorter session, but the point of today was just to introduce this very useful package and some of the cool things it can do. An example will fill function, please. Yeah, sure. So we can use the fill function in an example here. Let's find a column that we would like to fill. Let's look at data. So for example, we can look at the CD4 and viral load column. We'll do some nonsensical fills with it. So let's say over here, example of fill. So let's say we would like to say data fill CD4. I'll say example. So if we say data fill CD4, let's see what happens. I'm going to open this example data set. And you can see that it has filled. So fill by default fills a blank value with the previously observed value. So you can see over here in our, let me just cross these out. So in data, the first observed value is 643 for this row number 10. So that's why over here we have a whole bunch of blanks because there's no previous value to fill in, but 643 is the first value. So it has automatically taken that and filled in subsequent CD4 counts with 643. Of course, this is totally nonsensical because people without HIV would not have had this measured. This is just to show an example of how it works. Similarly, we can say fill CD4. Actually, I wonder if this works with 2 at a time. It's a good thing to try. We will learn together. is a spiral load VL. So fill CD4 and VL. Now you can see the same thing. Now it's filled viral load as well with the previously observed count. Another way to do it is example 2. Let's say data replace NA. Over here we say list CD4 equals unknown. So this will replace any blanks in CD4 with the word unknown. Let's see how that will. Oh, actually, this is a very good update. So can't convert character to match type double. So it'll only replace, because CD4 is a numeric value, it'll only replace it with another numeric value. So if I say replace it with 0, 0, 0, like this, now any blanks in CD4 will be replaced with, oh, where is example 2? With 0. And similarly, I can say CD4 equals 0, BL equals 0. So now this should replace blanks in CD4 with 0 and blanks in BL with 0 as well. So example 2. So here you can see zeros have appeared. Another way we might replace blank values is to fill in with medians, for example, which we can, medians and averages, this works for this particular variable because it's continuous. So let's say example 3, data replace NA CD4 with, let's say, median data, data CD4 NA equals true. So over here, this, if I run this in isolation, let's just try running this in isolation. This basically pulls out the median of the CD4 column in our data set. NARM equals T. This just removes any blanks. So by default, if I run this by default, it'll give NA. But if I run this, it should give a value, because it basically says ignore the blanks and show me what the actual median CD4 count is. So here, and now I'm replacing CD4 with this. And I say BL equals median, data BL, NARM equals T. Now what this will do is it'll replace blanks in CD4 and BL with the medians of those two variables. Let's take a look at example 3. Now it has replaced it with the medians. Hopefully that helps. I've just illustrated sort of 3 different ways you might use fill in blank observations. Hopefully that was helpful. If there's anything else people want to try out together, we can try out now. Is everyone kind of clear on the different ways of replacing blanks and then using fill? You can get quite creative with these.
Yeah, that's really clear, Ashna.
Sounds good. Yeah, if there's anything that is ambiguous or seems confusing, we can certainly debug together and see what works and what doesn't work. But yeah, the best way is just to try out. I believe there are over here, so similarly under packages, if you look for tidyr, tidyr over here, if I click on this is another good way to figure out kind of what different functions exist within this package. So I've shown you some common ones. I haven't shown you all of them, but you'll be able to see. So you've seen drop NA, you've seen expand, but there's a whole bunch of others that exist here. Fish encounters, no idea what that is. There are other ones that you can check out over here to learn a bit more about different functions within tidyr, but also you'll notice that tidyr kind of comes with its own data sets as well. So we have WHOTB data over here. That's quite useful to work with as well. So they have some religion and income survey. You have different inbuilt data sets that have functions you can use and try out. So I do encourage also to take a look at this and see if there's others that could be useful to you. The ones that I've shown you today, I guess, are the more common ones, but there are others that do have particular use cases as well. And yeah, they do have quite a few different data sets that you can play with. I think that is it from my end. That's kind of the main things we wanted to show. I see there's something in the chat. Maybe a short recap to it, reinforce conceptualization of why we need pivot longer and pivot wider. Sure, so pivot longer and pivot wider are quite handy in data visualization as well. So for example, if we go back up to where we showed pivot, there we go. So in pivot wider is quite useful if you would like to make a table more readable, for example. So we even saw this in our HIV example over here. So one data set was a little bit easier, so data wide. This is kind of easier or nicer to present in a table rather than something like this. So something like this would be a little bit more difficult for a reader to digest. So going from long to wide is very, very handy if you're trying to summarize a data set or make it easier to read, or adding a table to a paper, for example, that would be easier. On the other hand, going from wide to long could be useful for something like data visualization. So for example, if I'm going to go back to the PowerPoint here, so if here I'm going from wide to long, where are we? There we go. So going from wide to long is handy for visualizing. For example, if you think back to when we were learning about ggplot, one of the arguments in ggplot is separating something by color. For example, if I've got a bar chart and I like to separate the bars by color, you often have to say, specify what variable you are separating. So over here, it's quite difficult for me to say, oh, I'd like city to be one color and highway to be one color, because these are two different variables. But if I've pivoted longer, I can say, simply tell ggplot that road should be separated by color. So it'll automatically color city and highway differently. So pivoting longer, in my experience, has been quite useful for visualization, whereas pivoting wider is quite useful for having summary tables in presentations or papers. So that gives you an idea of when it might be useful to do these two different things. Of course, there are other instances you can use them in, but from my experience, those have kind of been two very good use cases for it. If there are others that people can think of, feel free to mention them as well. But those are two of the ways I found them quite useful.
Yes, and I think also Ashna, I can add on to that.
Sure.
But
Mm.
pivot longer and pivot wider, you can actually think of it from the spreadsheet or the Microsoft Excel point of view.
Mm-hmm.
They really help you to aggregate a huge data set. And you see what Ashna did is that the dataset had about 1,500 observations, but she was able to shrink that into just a few rows. Yeah, like this one now. You're able just to shrink that into 3 rows. That gives you a really powerful way that the type of case management has been aggregated. So these are really powerful functions when it comes to aggregation of data. And in a way, I can say, trying to summarize and deriving some quick or highlights from a given data set.
Thank you, Duncan. Yeah, these are fantastic ways to summarize. This, even though it wasn't included explicitly in today's session, this count function is like one of my most used functions. I often use it when I'm creating a data analysis plan, because it's a really good way of summarizing or aggregating the data, as Duncan mentioned, and really just seeing a snapshot of a summary of data, because then I can understand, okay, how many people fit within different categories of my data set, what do I have to clean, and it gives you a really good overview of your data.
Yeah, exactly.
Was there anything else people wanted to see another example of or found ambiguous? I'm happy to go through other examples. Or if you prefer kind of testing it out on your own and then coming next week with questions, that also works, whichever sounds good.
Yeah, I think that actually would be great. I saw some people actually joined in a bit late while you had just covered how the data line 20 was obtained. Maybe you can just
Ah,
quickly
yes,
go to line 16 and 20 for them to know it's not a different data set that we're using. We're just
sure. That sounds good. Yeah, so the line 16, this is the bigger data set that you have seen in previous sessions. So I'll just open it up. So this is the very long sort of HIV data set with 1,500 patients that you will be more familiar with. What I've done in line 20 is I focused on 2 different variables in this data set, and I've used this count function just to summarize how many people fit within different categories. So when I run this, over here you'll see in my console, this just basically tells me how many people fit within each category of these 2 variables I'm focusing on. And then the following code kind of dives deeper into this rather than looking at the bigger data set as a whole. It'll look at this particular summary. So that's where this came from. So it's not an entirely different data set, as Duncan mentioned. I will jump back over to this. But yeah, as I said, this cheat sheet here, and I can share the link in the chat here so you have it as well. This is very helpful in summarizing the main functions within tidyr and what they can be used for. And it has very helpful sort of visual summaries as well. I know it's quite hard to see on the PowerPoint here because we're not zoomed in, but perhaps I can show you what this looks like here. And this is actually really good if you have not checked out this GitHub account before. They have a lot of cheat sheets over here that are handy. There's a second page to this that we didn't dive too much deeper into because it's a little bit, they're not as commonly used with health data. Things like nested data frames are not as common in health data. So these ones I have found to be quite helpful and useful. But if you are curious, you can check out things like nested data frames and things like that. At least I have not used it before. I think others might have different experiences, but in my experience, nested data is not as common. But these are actually very, very handy cheat sheets over here. For example, one thing that we have gone over, which could be quite useful, data visualization over here. This is a really good cheat sheet. You can see it has cheat sheets or little cheat sheet functions for different types of visualizations you would have learned. Data import, different types of data importing. It's a very handy website altogether, very powerful. So would recommend bookmarking this and using it in your own practice as well. Yeah, that's kind of it from me today. If there's any questions, feel free to ask them now, or else I'll sort of hand back over to Duncan and Mary J.
Thank you so much, Ashna, for that really, really interesting session. And I think now for our learners, it is important to note that we are now building up on the concepts that we have been doing. So like what some elements of what Ludovic covered now, Ashna has just used some of those concepts, and now we are just building on more deeper concepts as far as utilization of R is concerned. So thank you so much, Ashna, and I just want to remind our attendees that you'll be back hopefully next week for R for Fun Club again. Yeah, same time at 7. Please remember to join, and we look forward to seeing you next time. And all the materials that Ashna used today, they will be uploaded on the RFC and the e-learning platform, so you can check them out. And Ashna, just a quick one. Did you have any quiz?
Yes, there's one quiz associated with this module.
Okay, wonderful. So you can also check out the quiz on the platform, try it out on your own, try the concept that Ashna has covered. And if you have any questions, we'll be back next week. You can ask the questions then. You can post your questions on the RFC page. We can get back to you, or we can get back to all the questions next week. Otherwise, thank you so much for joining, and we look forward to seeing you next week. Thank you so much, Ashna, for that session.
Thank you. Take care, everyone.
Yeah, thank you all. Bye. See you.
Bye.